Today, I would like to present and welcome Dr. Matthew DeCamp. He's an associate professor in the Center for Bioethics and Humanities and the Division of General Internal Medicine at the University of Colorado Anschutz Medical Campus. He's a practicing internist, health services researcher, and philosopher. Dr. DeCamp employs both empirical and conceptual methods to identify and solve cutting-edge problems at the interface of healthcare, policy, and bioethics. His research emphasizes patient engagement within healthcare organizational decision-making, ethical issues in the use of social media, big data, and global health ethics. With funding from NIH, he has served as the Ethics and Engagement Advisor for the Palliative Care Research Cooperative Group and conducted research on engaging patients and families in end-of-life and palliative care research. Dr. DeCamp is an award-winning teacher and mentor and has more than a decade of service on institutional review boards. Given numerous national and international talks focused on ethics of how we practice in both medicine and research, forcing each of us to look deeper into ourselves and broader across the way we are in our own communities. I've had the pleasure of being present at one of Dr. DeCamp's talks, which really made me think about how what we can do might not be what we always should do. And with that, I will turn it over to Dr. DeCamp.
Well, thank you for that really kind introduction, and thanks for the invitation, and thanks to all of you for joining today. I really hope that everyone is safe and well in what is continuing to be a challenging time for healthcare in the coronavirus pandemic. I'm eager to talk to you today about ethics, bias, and AI in medicine, more than just the data. Just to start, I don't have any relevant conflicts of interest to disclose. My research has been funded by a number of these groups, none of it actually related to AI specifically. So really what I want to accomplish today is just a couple minor objectives, small goals here. I want to describe why bias is such a pervasive problem for artificial intelligence. I hope to explain how bias is not just a data problem. I'll speak for around 45 minutes, and then hopefully we'll have a lot of time for questions and discussion about any of the issues I might bring up. Another way of looking at the presentation is that I'm going to start with the big picture. These are the maroon bells about 3 hours west of Denver, Colorado, the big picture of the forest. We're going to focus in a little bit on some of these blazing yellow aspen trees that are turning yellow right now this time of year out in western Colorado, to focus on some of the specific issues of bias, and then we'll come back to the big picture as we close. So I want to start with something that's a little bit provocative. You know, most bioethics lectures begin with something like this. They describe what we all have come to know as issues during the Holocaust and how prisoners were used for research experiments during concentration camps and during the Nazi regime. And so here's a prisoner being exposed to high altitude. Here's a prisoner being exposed to a medical experiment in freezing cold water to test hypothermia. And here, of course, are the physicians, the Nazi physicians on trial during the Nuremberg trials. And these, of course, were one part of a movement that became really motivational for bioethics, motivational for the principles of bioethics that we came to know in the Belmont report as respect for choice, balancing risks and benefits, and ensuring justice as fairness. But what a lot of people may not know is that bioethics and informatics have this really interesting intersection at the time of the Holocaust, because according to some analyses of the history of that period, in fact, statistics and informatics were the foundation of a lot of what the Third Reich was doing in Germany at the time. So if you ever have a moment to read the book IBM and the Holocaust, which discusses how some of these statistical counting, card sorting, and so on became instrumental to what was done in Nazi Germany, I'd really encourage you to look there. Now, you might ask questions about this. You might say, well, were these statisticians or informaticists actually complicit in the Nazi evils? Would thinking about ethics at that time have made any difference in the outcome that happened? Was this just an example of an ethically neutral tool, that is, the tool of statistics or informatics, being used for wrongdoing? And as we move to talk about AI in healthcare, I'd encourage us to keep these big picture questions in mind. As I said, after we dig into the details of the trees, we'll come back to them. I do want to start out by talking about the potential of artificial intelligence in healthcare. I think it's important, although much of what I'll say will seem somewhat critical. It's important to emphasize the potential that AI has in healthcare. I want to start with going over some basics of AI. You may see this picture in the top left. You may recognize it as IBM's Watson playing Jeopardy against some of the Jeopardy champions. Artificial intelligence itself is actually a quite broad term. It refers broadly to machines that can perform tasks typically thought to require human judgment or human intelligence. And artificial intelligence comes in different flavors or varieties. A lot of us talk about narrow AI, which is AI that performs a very specific or concrete task, such as we'll talk about, diabetic retinopathy diagnosis. This is distinct from general AI. General AI is capable of performing any or at least a range of tasks. And here you think more about science fiction robots than we would think about discrete narrow AI like diagnostics for retinopathy or CT scans and so on. Now, within these varieties of AI, there are actually many different techniques. I'm not an expert in them. I'm not going to go into them in much detail, but things like machine learning, either supervised or unsupervised, the use of deep neural networks, and so on. These are techniques all within the general umbrella of artificial intelligence. Now, some people actually write about something called super AI, which is actually capable not just of doing what we do, but doing it better. And probably a really interesting example of this is the thought of moral AI. That is AI that's so good, it's actually better than us ethically. That is, it doesn't fall prey to the same biases that we have as human beings. And in fact, it exceeds our moral capacities. Of course, lots of debate as to whether such a thing is even possible. So that's a little bit about AI. And one of the key features of AI that people talk about is what I would describe as the explainability problem. That is the idea that artificial intelligence takes inputs from data, big data, EMRs, patient records, and so on, goes through an analytic process and results in an output. But the challenge is that in some forms of AI, that analytic process occurs within a black box. The analysis is sort of inscrutable to human beings, to the scientists that are developing. And so I describe this as explainability, where the problem is AI's workings are not just unknown. It's not just that we, you or I don't happen to know how it works, but it's actually in principle unknowable. Now you can imagine already thinking about research with AI that this could complicate the consent process. I put could purposely in asterisks here because I think it's actually a question whether it could complicate consent, because sometimes we want to hold AI to a higher standard than maybe we do our everyday practices. Is it really true, for example, that we require principal investigators to know all the details of how the analytics of a clinical trial will work in everyday practice? Does it matter that they don't really know how it works per se? Does it matter that they may not know the exact mechanism of the drug? So you can see there are complications there, but nevertheless, the explainability problem is considered one of the key problems for AI in healthcare, partly because the thought is people won't use something that they can't explain or at least interpret. Now, there are big questions about whether AI in healthcare will live up to its hype. There's an expected billions of dollars, a tenfold increase over just a few years invested in AI. Eric Topol has pointed out that there have been dozens of FDA approvals in the past 2 years, where the approval process itself is somewhat curious or complicated as to how approvals will work for AI technologies at the FDA, but nevertheless, dozens of things are coming out, particularly in the imaging realm. And we've seen just an exponential increase in publications by year. This is a PubMed search on your left related to machine learning publications by year in PubMed, and you can see the graph just starts going off the chart. So a lot of hype around AI in healthcare. People wonder, will it live up to the hype? Now, the use cases of AI really go across the entire spectrum of healthcare, from research and development, screening for drug targets, diagnosis, as I've hinted at, in pathology, radiology, some of the pathologic uses of AI, for example, being images of potential melanoma, skin moles, the use in treatment decision-making for cancer treatments, sepsis profiles, sepsis programs, use in prognostication about mortality, use for resource allocation, for coverage decisions by insurers and payers of healthcare, and of course now a lot of attention to AI for its surveillance uses in public health and especially around COVID-19. And again, if you want a really good review of AI in healthcare, the citation is at the bottom of this slide. Now we can also look at AI uses across the translational science spectrum or cycle, where if we start with basic research, we know that hundreds of drug companies are using AI to help develop new drug targets, drug discovery programs. We actually know that in preclinical research, AI is being used here to provide efficient and accurate screening of drugs through virtual simulations of both human and animal biology. These are virtual programs meant to test drugs in some ways so that fewer humans are exposed to experimental drugs, fewer animals are exposed to experimental drugs, and so on. In clinical research, there are actually interesting uses of AI around trial conduct, largely around assessing site performance and data quality. To put this into more everyday terms, we would say that AI can be used to monitor data entry within clinical trials to determine whether there are problems with the trial or problems with data entry. It can find irregularities in large data sets that can reveal potential problems or errors in data. And of course, clinical implementation of AI and testing of AI in comparative effectiveness studies, diabetic retinopathy being a great example, where now there are in fact prospective comparisons. How does the machine perform against human diagnostic potential, and presumably to eventually implement these technologies. So lots of uses of AI, lots of potential across this entire spectrum. I want to spend a minute talking a little bit about public health and surveillance. This is another potential interesting use of AI. Stanford has had a program, you may have heard about it in the news, where they're looking at vision-based smart hospitals. What that is, in effect, is the use of AI via visual imaging and cameras to help detect things like falls, patients at risk of falls, hand washing, and so on, where the images that come from cameras placed in intensive care units are analyzed by artificial intelligence to look for performance of everyday tasks. You can already, I imagine, think about what some of the privacy, legal liability, ethics issues might be in that setting. AI, of course, has been used during the pandemic, both for contact tracing and for other purposes in Europe and abroad. You may have heard about some of the mobile apps that are being used for contact tracing during COVID-19. And some of this, I'll just point out, gives people and ethicists a little bit of the heebie-jeebies. That's not a technical term, but if you see this figure on the left, this is actually a drawing from the 18th century of the ideal prison, where at the center of the prison is an observer that keeps a watchful eye within a circular prison so that prisoners are continually monitored for their behavior. It's called the panopticon. The philosopher is Jeremy Bentham, who first imagined this as actually a progressive movement for prisons in the 18th century. So lots of uses for AI. You can imagine many ethical issues coming up with every one of these potential uses. We've hinted at privacy. I've hinted at the problem of informing patients. You can imagine it could be challenging to get consent if the machine being used is inexplicable. You can imagine issues of clinician choice, balancing risks and benefits, how do we deal with errors, and so on. But today I'm going to focus really on these issues of bias. Though I'm also going to hint, as we go along, at how issues of bias can in fact affect other ethics issues as well. Happy to discuss some of these more discrete issues of choice and beneficence in the Q&A, by the way. Just for today, I'd like us to focus a little bit more on bias. Now, these ethical issues that I've just pointed out are not theoretical. You may have caught news stories like this one, where IBM's Watson recommended unsafe and incorrect cancer treatments. They actually recommended a particular treatment to a patient who had a very clear contraindication to that treatment. So there's an issue of risks and benefits with the use of AI. And on the privacy side, you may have caught this story from last year where Google, the University of Chicago, and actually a couple other academic institutions were involved, were actually sued over data sharing between the EHR and Google, in part to help Google develop its AI-based algorithm. So lots of these issues now coming up in the real world. And lastly, again, we're in coronavirus 19. It's worth pointing out that some of these issues of privacy have come up related to apps that are used for contact tracing. Examples of this in South Korea, where the app actually inadvertently revealed private details of people that were supposed to be protected by the mobile app. So not just theoretical, lots of these issues we're seeing pretty regularly now in the news. So with that background about AI in healthcare, let's really focus for a little bit now on the trees and focus on what I call the pervasive problem of bias in artificial intelligence. There have been a few prominent examples of biases in the news with AI in general. One of the more prominent examples was the use of an AI-based tool to help determine prison sentences and prison time for those who've been convicted of crimes. And in fact, the algorithm itself was biased against African American, against Black individuals who were in the criminal justice system, preferentially recommending sentences for them. You may also have heard about Google's facial recognition software, which performed unequally, inequitably across different races, biased against darker skin, another high-profile case of AI biases. But some of these are actually already showing up in healthcare. So let me give you 3 examples on this slide of where we've seen biased algorithms in healthcare AI. This first one is from Science Magazine. Really high-profile case, got a lot of attention, where a commercially used algorithm, it was used to direct resources at sort of the payer level in healthcare, actually disadvantaged Black patients for receiving particular care resources. This was a post hoc analysis of this algorithm, scrutinized and analyzed in Science, clearly revealing bias. Not to pick on Google, but it's had another example that's been in the news, and that's that its mammogram diagnostic AI was found not to account for racial differences. So in other words, the diagnostic performance of the algorithm seemed to differ based on race or ethnicity. And then finally, here's a publication that described a situation where case management for early hospital discharge would preferentially have given resources to wealthy white individuals for early discharge as opposed to other individuals within the hospital. And I say would have in this case because thankfully, as is described in the article, this particular bias was caught before it was implemented within the hospital. But 3 really prominent examples of how we're seeing biases in AI-based algorithms in healthcare. So why is bias in AI such a, what I describe as pervasive problem? The usual answer goes something like this. We go back to this simplistic view of AI as data collection through data processing to data interpretation and outputs. And we say that, well, here's the problem. The problem is garbage in with data inputs leads to garbage out in data outputs. And there's no doubt that this is a really significant problem for AI in healthcare. Data are a large part of the problem. We know that there are radical inequities historically in clinical trial participation that results in data sets that are not representative of the broader population. We know that there are historical patterns of racism and inequities in access to care that cast a shadow over current algorithms. In fact, that was the problem with the commercial algorithm that was published in Science Magazine related to healthcare resources. If you get into the details of that, in fact, the algorithm was biased because of inequities in access. We can say more about that in the Q&A. And what's worse in this case is that algorithms that start fair, in other words, even if we have a fair algorithm, if the algorithm is adaptable, meaning it can change over time, not many are, the algorithm itself can actually learn patterns of biases over time and repeat them. And this can happen even when the variable in question is removed. So you might think, well, here's what we can do. We'll just take the problematic variables out of the algorithm. We'll take out race and ethnicity and so on. But you can't just do that, because the algorithms are complex enough and smart enough that they will in fact learn the patterns even when we've removed the variables. But today I want to suggest the problem may even be worse than a simple data problem, than a simple garbage in, garbage out problem. And I want to give some examples of biases that may arise even if we had a perfect algorithm. Let's take a step back and think a little bit more philosophically about what is bias. We use that word a lot. We maybe use it interchangeably with discrimination or stigma or other sorts of ethics-related concepts. But bias, in effect, could be defined as just any disproportionate or systematic weighting of an idea or a thing. That's a bias. We can think of biases in science as well. And of course, we know that bias can be intended or explicit or unintended and implicit. And of course, there's been a lot of great work over the past 10 years or so related to implicit biases in healthcare. We also know that bias can be the product of cognitive errors, like anchoring bias. If I'm in the clinic, as I was yesterday, I may think about today's patient and I may be anchored to a diagnosis because of information I already have, or a patient I've seen earlier in the day, and that anchors me to a particular diagnosis because of what I've seen previously or the information I have. So bias can be the product of an error, or it actually can be the product of cognitive intent. So the example here could be reporting bias, that is only selectively reporting certain things in a journal publication, which in effect is a version of scientific misconduct. Now, if we keep this more general idea of bias in mind, I think we can start to see that biases have implications for far more than just the data. And if you're interested in learning more about bias, the Catalog of Bias at the University of Oxford is a really interesting and helpful online site that discusses the many biases that exist for human beings and in science. It may be a little bit depressing to see all of them, but it's certainly a worthwhile resource to go to. So I like to think of biases in the data really as the tip of the iceberg. This is a figure from a recent publication related to bias in the Journal of American Informatics Association. The implication of understanding bias in this more general way is that even if we were to solve the data problem, and that's hard enough, and even if we created a fair model, what we would describe as latent biases, that is biases waiting to happen. This is a play off latent errors in complex system. Biases waiting to happen lie beneath the surface, even when we have the perfect model. So what I want to do now is give 3 examples of biases in AI that I think are slightly different or distinct from being simply a data problem. And the first is the bias in selection of the scientific problem or task to be solved. This is a bias that is systematic favoring of certain problems or tasks that are worthy of solving. And this is itself a bias because it's a bias in the choice of what we're going to use AI for. I think of it like a sieve. We have a sieve that filters out what are the good ideas to be solved and what are the ones that we're not going to solve. And this sieve, instead of allowing fair discussion of different ideas, only allows certain ideas to trickle through as being worthy of solving by artificial intelligence. Now, what reasons do we have to believe this might be an issue at all when it comes to science and AI? Well, we certainly know from recent publications that the choice of topics seems to contribute to the lower rate of NIH awards to African American or Black scientists. In other words, there seems to be a bias in the choice of things that are funded by the NIH. This filtering of ideas, it's systematically disadvantaging certain groups. And we also know, and this made big news last year, that there may be a problem, or there have been concerns raised about AI ethics in that big tech the Googles, the Microsofts, and so on, came under a lot of scrutiny because they had actually proactively developed AI ethics boards, but there were real concerns raised about the composition of those boards, whether those boards would be systematically favoring certain ideas over others, whether these boards needed to be independent of the company, and so on. So in other words, the ideas of conflict of interest, and the idea that in many cases, AI is being developed jointly between healthcare institutions and industry. And so naturally concerns have been raised that this could create a potential conflict of interest where the types of problems that are solved are biased against other types of problems that you or I might care about. So bias in the selection of the scientific problem or task is one way that AI can be biased, even if we had perfect data. That, remember, is the point, that even if the data were perfect, we would still have this problem at the top of which ideas are chosen as worthy of being solved. Now, the second bias I want to explore is this idea of biases in choices. Automation bias is the phenomenon where we tend to over-rely on technology or follow it unquestioningly. We can see this or imagine this happening with clinicians who follow AI because of increasing time constraints, legal liability concerns, and so on. In other words, make it in practice that the clinician's choice to follow or not follow a particular AI recommendation or an AI tool tends to be slanted in favor of following it. So biasing the choice, biasing the action that's taken. I've also thought about this happening for patients who come to believe that the AI knows them and therefore become locked into their past selves. What's a technology like this look like? This may be a bit of an opaque idea. The idea here is that there are AI technologies being developed that look at people's preferences over time, the choices they're likely to make in healthcare, much like you would have things recommended to you based on Amazon shopping, based on online browsing, based on Facebook. That is the idea that the past is predicting their future. Well, this is actually happening now in healthcare, where we might say, well, here's what we want to do. We want to predict people's advanced care planning preferences based on the decisions that we can see that they've made in the past. And what this does is it creates a certain choice bias, or a bias that's based on past decision making. It would seem to assume, for example, that the person I am today is the same as the person I was 10 or 15 years ago, and that my choices should therefore look exactly the same. You can sort of imagine what this might be like in practice. If you were fed information from an algorithm that said you are likely to do X in situation Y, it probably would make you think, well, maybe the algorithm does know me. Maybe this is what I should choose in this particular circumstances. And it comes to affect that choice architecture of the decisions you might make related to your healthcare in practice. So biases in choice can also be particularly problematic in settings of historical distrust, racism, and so on, because the extent to which choices are shaped by those structural features of our environment, it again locks us in to reifying and reinventing those same biases in practice over time. So biases in choices. Now, the third example is what I call biases in application. This occurs when certain AI applications are only used or accessible in particular settings, something that can be called privilege bias. Of course, our hope is that AI will actually reduce privilege bias by leapfrogging certain barriers in access. So we go back to that idea of using AI-based diabetic retinopathy diagnosis. The promise of this technology is that we could actually get diagnostics to rural areas that have historically been underserved, and in fact, increase access to that particular technology. But it's important to point out that that will not necessarily always be the case. It may not be the case that access to AI-based technologies go to rural areas first. In fact, it may be far more likely that AI technologies are accessible in higher income academic settings and so on, which again create biases in the way a particular technology is applied or diffuses throughout a particular environment. So in other words, I think we need some accountability measures for ensuring that these promised benefits of AI and its risks are actually accessible equitably. So biases in application or privilege bias. And on this slide at the bottom is what I think a really excellent article on biases of different kinds in AI. It's in the Annals of Internal Medicine. If you're interested in this topic of bias in artificial intelligence, I would highly recommend that you look at that particular article. So what are the implications, to maybe restate them in a different way, of this more comprehensive account, or at least suggestions of a more comprehensive account of bias? You know, this would suggest that issues of bias are primarily, but not only, issues of justice. They also affect choice and our obligations of beneficence because they affect well-being. And I think you can see that in the examples of AI affecting choices in a certain way, and also AI affecting issues of welfare and well-being by determining, again, which problems are going to be solved, which healthcare issues deserve solving, and which will in turn affect who benefits from a particular technology and how. It won't be enough to create fair systems because these systems operate in an unfair world. So we can't think that technology is going to solve this problem in and of itself. It also won't be enough to keep systems as decision support only or non-autonomous AI. So what you'll hear a lot in the AI world is, well, as long as we keep it that these are simple decision support tools that simply advise people in practice, whether they're policymakers, clinicians, patients, and so on, then we're safe because we're preserving choice. Well, as I've suggested with the choice example, this may or may not be the case. It could in fact be that the presence of the technology shifts our choices in certain ways that lead us to either follow them unquestioningly, or perhaps on the other hand, we could even follow them not at all if we simply can't explain or can't interpret what they're saying. So choice too is going to be affected by biases in AI. So what can we do? I've tried to lay out this problem we have with AI. There's a data problem. There are broader bias problems. What is it that we can do to help solve some of these issues of bias as we develop machine learning, artificial intelligence technologies? Well, another thing you'll hear in the media is that building trust in artificial intelligence is the answer. Here's a snippet from IBM. Lots of the other technology companies are saying what we need to do is build trust in AI. I'd like to suggest that that's not the answer, or at least that that's a problematic answer. At the first glance, it's also because we don't just need to build trust, that is your trust or my trust in AI. We would actually need to build trustworthy AI. So that's an initial problem with this concept of trust. But in fact, there's a deeper problem with trusting machines or trusting artificial intelligence, because the richest concepts of trust actually require a number of the following. They require placing something of value at risk to another's discretion. They require an expectation that what was entrusted to the other party will be fulfilled. They require an implicit or explicit promise of the trustee to the trustor about that particular arrangement. They require mutual understanding of both parties. They require discretion on the part of the trustee regarding how that trust could be fulfilled. And they require confidence in the motive of the trustee. Now, a lot of these factors you can recognize come from classical relationships of trust, say between patient and clinician, patient and attorney, and so on. Not only is AI, by these definitions, just incapable of trust, the machine itself, at least now, doesn't have motives or confidence or discretion, but also I think as a simple matter, I don't want to trust AI. I don't want to trust that the AI is biased or not. I actually want to be assured empirically that it's not biased. So I don't think trust is the answer, and maybe a misguided answer, for how we should deal with biases in these new technologies. So what can we do? I'd like to give 3 suggestions and happy to discuss more in the Q&A. We certainly must address issues of data causes of fairness in the algorithms, but I don't think it's a matter of tweaking them or simply correcting them after the fact. Addressing these particular biases in AI simply requires us to address these longer standing issues in diversity among scientists, issues of problematic clinical trials recruitment, which we're seeing now, by the way, in the COVID vaccine studies, lots of problems with recruiting marginalized or underserved populations. We need to deal with health system distrust. We need to deal with structural racism, implicit biases, and so on. We can't just have the data and tweak it after the fact. And that's one of the solutions you'll see to particular biased AI algorithms, is to tweak them after the fact to correct for their biases. I think relatedly, we must address these issues of bias ex ante, that is, before they occur. We can't wait for a science publication to reveal biases in a major commercial algorithm that's used to direct healthcare resources. And I and others have even suggested that we may want to consider issues of bias as actual safety issues. You remember I made that connection between latent biases and latent errors in complex system. I wonder what it would be like to think of bias itself as a safety issue, because it affects different people disproportionately differently and results in particular systematic disadvantages. Interestingly, recent FDA guidance on machine learning algorithms in healthcare, in fact, doesn't even mention bias in the guidance as a particular problem to be solved. We have this continued view of, well, as long as we make sure it's safe and efficacious overall, we need not concern ourselves with biases. And I wonder what it would look like if FDA guidance instead explicitly addressed biases. Third, I think as AI is implemented, we must use some of our translational D&I scientists to support dissemination to not just more people, but to ensure that it goes to the right people. Sometimes there's a view of dissemination or implementation that says we just need to get stuff out to the most people without reference to who those people are. We may want to employ concepts of equity with D&I science, with translational D&I science, to ensure that we're actually addressing the right people. Here's an example of what I think could be managing biases ex ante. This is an MIT AI tool that actually was explicitly developed at the outset to be sure that the tool itself would perform equally well for white and Black patients, in this case related to women and breast cancer. So it's possible to do this in advance. We just need to expect it more of our technologies, and I think keep demanding that issues of equity and bias are addressed up front. We can't wait until later. All right, so I've started with the bigger picture, gave us, I hope, some thoughts to think about, and some things that may generate questions for our discussion in a few moments. Now I want to step back and go to the bigger picture again of the use of technology in healthcare. So you might still think, going back to that first provocative example and the questions that I proposed there, wait a minute, these are just how AI is used. They're not problems with the technology itself. It is the idea that tools are neutral, and it's really just how we use them that can be problematic. So on the one hand, we do think of tools as things we use to achieve our end goals. On the left here is a scalpel, a simple example of a tool that helps us achieve our goals. On the other hand, there are philosophers, this is Martin Heidegger, who suggested that tools actually fundamentally change the way we see the world, and in fact can start to change our end goals and our ethics values. That is, tools aren't just neutral things that we use. The presence of tools in our lives and how we end up using them actually ends up changing our values. And in fact, scholarship in sociology has pointed out now for a couple of decades, specifically related to computers in the early days, this is even pre-artificial intelligence, that the tools we use can actually change the way we think and act toward each other. I mean, now if this is true, it's really true that the tools we have, that the presence of computers and technology and other things in our lives, if this is true, it has significant implications for ethics. It's not just that we need ethics to inform our use of tools. If tools are not neutral, we must continually be aware of how our core values and our technologies affect each other. Now, before I move on, I'll point out that this is not necessarily a new phenomenon, right? There are studies that have shown how, for example, the development of language has changed the way we think and shaped the way we think and act toward each other. The development of mathematics has affected the way we think. Development of binary numbers changes the way we think about numbers. So not necessarily a new phenomenon, but one that seems to be developing and certainly just as applicable for AI as it is for these other even seemingly rudimentary sorts of technologies. So how might AI change the way we think? Well, just as some questions, will it result in reductionism about patients, that is, seeing them as packets of data? Could it depersonalize care or enable greater empathy? In fact, if we use the tools properly, might it change the way we design healthcare spaces for the sake of surveillance rather than healing? Think back to that example of AI-based surveillance in a hospital. You can imagine that once we have this technology and it seems to work in the current hospital, might we start to say, well, this technology of surveillance could actually work better if we redesigned the hospital in a certain way so that the cameras have better access to viewing this part of the room, and this camera can see this better, and this analytic could be better. So now you can see it starts to change the way we think, because we're designing healthcare spaces not for healing, but for the sake of improved surveillance via the technology. And I think we could probably brainstorm other ways that AI could potentially change the way we think. And there have been some who have said or suggested that some uses of AI should be simply off limits. There are, in fact, some questions that we ought not bring AI to bear upon. This is one among a number of examples of mortality prediction tools using artificial intelligence. And I'll just suggest that some of these tools have incredible accuracy within certain data sets, up to 2 years out, able to predict death somewhat reliably. And some have questioned whether we should be using AI for these sorts of existential decisions at all. And I'll also point out that it's highly likely, based on everything I've just described, that a tool like mortality prediction could end up being biased in the same ways that other tools have been biased because of historical inequities in access to care and so on. And that these tools have also been put forward during the coronavirus pandemic as being ways to predict who gets resources during the pandemic, who gets the ventilator and so on. When it's decided based on a mortality prediction tool, when it's decided based on mortality prediction tools using AI, these biases will likely creep in and likely result in biased outcomes. So we're right at the time, right around 45 minutes here, and I'll just give you a few concluding thoughts before I hope we have a bit of discussion. Press me on some of these concepts I presented. AI does have great potential for improving health and also for improving access. There's no doubt. But I think it's critical that these issues of bias and equity be at the center of AI, not an afterthought. We're often taught about the rising tide that lifts all boats. We often wait for that to happen in the real world. And I think that we need to keep pressing for issues of bias, issues of equity to be addressed at the outset. Second, we're not going to fix AI biases simply by fixing the algorithm. It's yet another opportunity and should be another motivation for us to address structural and social issues of power, class, and race. As AI moves forward, I think we must continue to advocate for decisions and decision processes that both account for issues of equity and include marginalized communities and people in these decisions. The introduction mentioned that I have done prior research in patient and community engagement in healthcare, and it's certainly, when it comes to AI, another opportunity where engagement of communities in our decisions improves the justice of the processes and likely improves the justice of the outcome. So I'll stop there. And thanks again for your time and attention. I'm happy to address any questions that have come in via the chat or verbally or whatsoever.
Thank you. Thank you, Matt. That was that was a very, very eye-opening and interesting presentation. I appreciate it. I feel like I have been talking about how biased our healthcare data are when we're trying to develop clinical prediction models and the use of machine learning algorithms and AI specifically to help us make healthcare decisions without really thinking about where the data come from and how the data are obtained, how they're stored, how they're asked. So I really appreciate this talk. We do have some questions. So for programmers who are routinely asked to generate learning systems using AI and machine learning, how do they safeguard against letting their own biases unknowingly alter or potentially bias their own programs and decision rules?
Well, that is a really challenging question, and it's actually not a bias that I was going to say, it's not a bias I specifically talked about, but there is, some people would call sort of there can be philosophical biases that, yes, impact the things we do on an everyday basis, sometimes sort of unknowingly. Of course, one of the key steps that you'll always hear is making sure we are aware of, we're reflexive in acknowledging our own potential biases. And that's a start, but I also hinted at in the presentation that we have this problem about implicit bias. You know, there are biases that we actually are not conscious of, and so being aware of them can't possibly be the only solution to that sort of bias. One of the things that's interesting about this question is I'm not sure if it means to imply that an individual is doing this all on their own, but I think this may be an opportunity where team science and collaborative science is actually really important for monitoring biases, because I'd hope, it's not my world, I don't do what is described in the question, but I would certainly hope that it's not merely one individual responsible for the programming and the eventual full outcome of any particular project. So I'd hope that there are others involved. And there are ways to do the types of bias analytics like was done in the science paper after the fact, be sure that the outcomes themselves aren't biased. So I hope that's a start to answering that question. It may not be the full answer, but it's a great question for all scientists, by the way, not just programmers.
How much of the bias issues are due to the black box nature of the AI?
How much is a tough question. It's certainly the black box nature contributes to the problem of making potential biases less able to be analyzed and scrutinized. It's hard to say how much of the bias actually could come from them. That probably depends a lot on the particular technology. The black box nature certainly makes it possible to have the kinds of adaptability over time as the system learns, and to have those be inscrutable, for those outcomes. So that's a case where, as much as I was talking about how important it is to do this ex ante and in advance and so on, it's actually just as important to do the post hoc analyses to be sure that the outcomes themselves aren't biased. And you can actually see that a little bit in the example I gave about the care management algorithm that wasn't used. Before they deployed the algorithm in the health system, they thankfully tested it. And once they saw that the outcome was what it was, almost like a Robin Hood effect, reverse Robin Hood effect, they clearly pulled back and said, well, we're not going to implement this because we've seen that the output is biased and something is wrong here. We're not going to do it.
So someone actually did also responded to the previous question and said some feminist philosophers of science would say that the programmers, users of AI, should disclose their biases and let the community work it out, so to speak.
Yeah, I think that's back to that maybe the first question, and saying it shouldn't be done solo, because when we're within our own heads and doing our own thing, it makes it far harder to recognize our own biases. And I really appreciate that point.
So given that structural racism is such a long-standing problem, for lack of a better word at the moment, how on earth are we supposed to even conceptualize developing unbiased algorithms using the data that we have?
Well, the pessimist in me wants to say it's probably impossible at the moment. That alone may be an important observation or fact. In a way that shifts the goalpost, right? If we know that basically everything we're going to create will have biases in it, it becomes not about thinking we can create the perfect algorithm, but it becomes about shaping the algorithms in ways that at least lessen, reduce, move towards eliminating biases. And I actually think that could be maybe important, because I think there is this view out there that we're going to get to the perfect algorithm. And I think that's like the fountain of youth. That there won't be a perfect algorithm that's going to come in and solve our problems. And I in the coronavirus example, I think is another good one. I think there is a large part of policy and even bioethics that thinks that the tragic decisions we thought were going to be made in New York or other places, and still may have to be made if there's another surge, that those tragic decisions, if we just had the algorithm that would predict survival, now we have the perfect algorithm and our problems are solved. But the problems aren't solved, right? I mean, these are decisions about life and death, about who gets what resources, and the mortality outputs we know are going to be biased by historical issues of inequity and access and so on. So I don't mean to be pessimistic. I don't think there is a perfect algorithm out there. I would certainly like to see, and maybe it's been done and probably is being done, the idea of using these algorithms to detect background social, structural inequalities and so on. I've seen some of that done, where algorithms, as they run over time, can actually be scrutinized to show that they're revealing a background inequality. There's a postdoc who's now at Penn State, was previously here, working on that exact problem. And so it's interesting to think about using AI to actually detect structural inequalities and structural racism.
So to be optimistic, maybe on specific problems, we can design AI solutions with bells and whistles, of course, including explaining the potential biases in the solutions, something like AI model cards.
I like that idea. And, I will say, I've been criticizing the idea that, or the concept that we can't just think of it as a data problem. But in fact, even, and I tried to hint at this, even if we think of it as a data problem, solving the data problem actually requires dealing with all these structural issues, right? It's the critique of the data-based solution is really, in my view, the critique of tweakings or sort of adjusting the algorithms. As I tried to hint, even if we took it as only a data problem, the issues of recruitment, of data quality. For example, one of the things we've struggled with here is a program that's trying to link data between different sources to be able to use for algorithms. And no one will be surprised that linkage algorithms perform poorly differentially among different groups that don't speak English, groups that change mobile phone numbers a lot. The linkage performs more poorly, and that's going to result in an algorithm that also performs poorly for those particular groups. But the only way to solve that data problem is actually to address these broader structural issues that affect those populations every day, not just when it comes to AI.
Would you recommend then, given that there is so much structurally that we don't understand, and to have somebody on our teams who might be considered very knowledgeable or have expertise in that area, whether it's just focused on sort of how, for example, structural racism affects healthcare, having somebody who really understands that piece there, as opposed to us constantly doing something like controlling for race or correcting for race.
I think that's critical as part of the solution. I think that some of these issues and we even to go on with that data linkage example, some of those issues don't come to the fore unless someone is there to speak to that particular problem. Because I think sometimes this is not to critique data scientists, but I think sometimes data scientists, they see the data problem, like they see that there's an issue with name spelling changing or being different in different databases, probably because of language barriers and so on, but they don't see why that's a problem. And it's incredibly important to have that sort of contextual information as part of the discussion, because it may open new avenues for solutions as well. Yeah, I see in the chat, by the way, Weapons of Math Destruction by Kathy O'Neill. That is an excellent book. Mm-hmm. If you want to be really pessimistic, I don't recommend it. But if you've not watched on Netflix, The Social Dilemma, which is about technology and social media technologies in particular, exploiting psychological weaknesses in human beings to get them attached to their particular devices, it's worth watching, but not if you want something that's uplifting.
Thank you. Last words as we're rounding up to the hour. What would you like? How do you think that we should be approaching our colleagues who are wanting to jump on machine learning, AI algorithms to solve the medical issues that we're facing? Most of us, probably half of us are pediatrics, half of us are over at the adult side, so it wouldn't matter which group. But how should we move forward now that we have a better sense of all of the issues?
Well, again, I don't mean to be pessimistic about the tools. These tools are powerful. They are going to change healthcare, and a lot of it can be for the better, right? I mean, I think there is a lot of potential. I have found that these questions of which problem are we solving and why are we solving it is number one, is still a critical question to ask. And then number two, I find that in most discussions I've been in about technologies, the issues of equity and bias have to continually be brought up in every project, because I think it's far too easy to fall back on thinking about, I don't want to be philosophical about greatest good for greatest number and so on, but it's far too easy to get into that kind of a mindset. And so I think making equity an explicit part of almost every conversation about technology is still just sorely needed. And I think just has to be done with any particular technology. And then lastly, I'll try to slip in that this issue of engaging communities that may be the ones affected by the technology to help them design and develop it. It's probably a third critical piece. We still don't do that enough. We still don't do it well enough. And we need to do it more.
Well, I want to thank you on behalf of our CCTST, as well as all of the attendees, for giving us a very thought-provoking talk. I'm sure that we're going to have lots of discussions after this, and I really appreciate your time, Dr. DeCamp.
Well, thanks for having me. Hope you have a good rest of the day.
Absolutely. You do the same. Thank you.